Hello. So today we are going to solve 25th August Gigs for Gigs problem of the day. That is minimum moves to sort permutation. What this problem is saying is we have given an array and that is containing integers from 1 to n exactly once. And we need to sort the array in the increasing order. And we have to find the minimum number of operations that required to sort this particular array in the ascending order. What do I mean by operations? So operation means you can pick any element and move it either to the beginning or to the end of the array. Okay, let's go to the whiteboard and see what it is saying is. So consider you have given a array as 1, 3, and 2. Okay, so this array is not sorted. The sorted version of this array will be 1, 2, 3, right? But how you will sort this array with these operations? You can either move any element to the end of the array or either you can move any element to the beginning of the array. Consider if I'm moving this 2 to the first starting of the array, there is no meaning of, right? Because 2 is, we can write this or we can move this 1, 2, 3. Okay, so there will be two operations required in this operation. If I'm moving to the beginning of the array and then 1 to the beginning of the array. But there is another version also. If I move 3 to the end of the array, it will look like this 1, 2, 3, and it is sorted. So we can do this operation one, and we have to find the minimum number. So we will return the one number of operations required to sort this array. Okay, so let's uh, take one or two more examples so that you will get better approach. Okay, and consider we have something like array 3, 1, 2, 4, and 5. One more thing that you have to pay attention is this array will contain exactly elements from 1 to n exactly once, and all elements will be 1 to n. There will be not like 6 present in this 1 to 5 array. Okay, this is a very important observation and this will help us to solve this problem. Okay. So as you can see in the constants also, array dot size is less than equal to 10 raised to power 5 and array of I. It means every element is from 1 to array dot size and array dot size whatever we are going to choose. So here array dot size is 5. So every element is from 1 to 5. Okay. So let's see how you will solve this. So consider to make this sorted array and consider if I will move any element, like if I don't know, if I will move, consider 4. Okay, 4 and 5 are already sorted and they are at end. So ideally approach is either move 3, either move 1 or 2. So I will move, consider 2, 2 to the beginning. So if I will move 2, so it will something like 2, 1, 3, 4, 5. Okay. If I will move 1, so to the beginning, it will look like 1, 2, 3, 4, 5. So it means this is sorted. This is one operation. This is one operation. So total we have done two operations. Okay. So this is the one approach. Other approach that can be like you can move any other element. Consider 3. If I'm moving to the like at the end, so it will look like something 4, 5, 3. Okay. If I will move 4 to the end, 1, 2, this will look 5, 3, 4. And if I will move 5 to the end, it will 1, 2, 3, 4, 5. So it means here we have required three operations. So minimum is 2. We can achieve in minimum, we have to achieve in the minimum number of operations. So we will, output will be 2. Okay. So hope you understood the problem, like what we are trying to achieve is, so our basic understanding is like, first you have to understand what is the problem is saying. Okay. This is the must. Then you can try multiple approaches like how you are thinking. Okay. So let's see how we will, think this. Let's take the same example to understand 3, 1, 2, 4, and 5. Okay. So consider we have array of elements. Consider we have a lot of array of elements and we have multiple things. Okay. X plus 1, consider X plus 2, because this array elements are given in the sequences. Okay. And consider till Y. We have some elements present here. We have some elements present here. Okay. So what are approaches? So basically we have to find out how we can sort the array, how we can sort the array in the minimum number of operations. So if we find out what are the already sorted elements present in this array, okay, what are the already present sorted elements in this array? So in this array, what are the sorted elements? 1, 2 is present. 3, 4, 5 is a one sequence. 1, 2, 4, 5 is a sequence. Okay, that is present. But in that case, which will be give us the minimum value. Minimum value will be like, consider we have some elements present in this manner, like x plus 1. This is the sequence present. Okay, so it means all the element present less than x, all the element present less than x, we have to move those elements to the beginning of the array, and all elements greater than y, we have to move to the end of the array. So this is a simple observation. Consider, I'm repeating it again, like if we have a sequence of elements from x to y, and those are present in x plus 1, because every element is from 1 to n, so there can be sequence possible in this input array. So it means we have to move every element less than x to the beginning of the array, so that to make it sorted, and again for greater than y to the end of the array, so that complete array is sorted. Okay. So how we will achieve this? So if we somehow find out longest sequence present in this array, longest sequence present in this array, then we can, what we can do. So total length of the array is n, and if we deduct this length that is already in the sorted array, and it's the longest sequence present in this array, so we can find out these minimum, these other elements. And what we have to do, this just like finding the longest array, longest longest sequence, and if we subtract this, then we will get these elements, we will get these elements, and this will be their answer, right? So how it will work, like consider with this example. So what I'm trying to say is, like, what are the longest sequence present in this? So from 1 and 2, one sequence is present. For 3, 4, 5, this sequence is present. So there are two sequences present, 1, 2, and the other sequence present is 3, 4, 5. Okay. So what, let's take 1, 2. So it means less than one element will go to the beginning, there will be no element. But greater than 2, there will be three elements that are going to the end. Okay, that will be going to the end. So it means three operations we will require in this. Okay, so in this will require three operation. But for 3, 4, 5, it means greater than 5 we will move, there will be no elements greater than 5. But less than 3, we have two elements that we need to move to the beginning level, so it will require two operations. Okay, how it will require three operations, let's see. So for if we taking 1 and 2, so 3, 4, 5. Okay, how it you will sort this array? So consider you will first move 3 to the end, like as we have seen earlier also, 4, 2, 5, 3. You can move 3, and then you can move 4, you can move 5. So it will require three operations, as we have seen. But for 3, 4, 5, we can only move 2 at the beginning level and then 1 at the beginning level. We will have a sorted array in the minimum operations. So our problem reduced to, you have to find the longest sequence that is present in the input array, and then if you will deduct this longest sequence from the length of the array, you will get the answer. Okay, you will get the answer. So how you will find the, now the problem is reduced to how you will find the longest sequence of the array. Okay, let's see this. Hope you understood this approach, how we are came up to this point. So consider you have 3, you have 1, you have 2, you have 4, you have 5. Okay, same example. And you have to, now our problem is reduced to, we have to find the longest sequence present in this input array. Okay, so consider this index is 0, 1, 2, 3, and 4. This is array we have given. Consider, for finding the longest sequence present in the array, we have to first store the, like, which value is present with the which index. Okay, so consider I have some data structure and I am storing like 3. 3 is present at 0 index, 1 is present at 1 index, 2 is present at 2 second index, and 4 is present as third index, and 5 is present at fourth index. Okay, so this we have given. Okay, this, consider this is a one of the data structure. We will see which data structure we can use for optimization. But consider something we have, and we know like which value is present at which index. Okay, now I will start from because we have all the values 1, 2, 3, 4, 5. I am starting for consider 2, 3, 4, 5. These will be the sorted elements. Okay, so I'm starting from consider 2. Okay, if the position of 2, okay, if the position of 2, if the data structure it is giving me the position of 2 is 2, like this is present at index 2, and position of 1 that is present at 1. So it means if it is greater than this, it means these are sorted array. It means this is present in the sequence and it's are present in the sequence, sorted sequence. So we don't need to touch. We can say our longest, consider I am maintaining one variable that is longest, and I am maintaining one variable that is current. Okay. So current initializing with 1, because every element, if you have sorted array or not, like if we have if we have input array in the decreasing order 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So but still one element is the considered as a sorted array. So I'm starting with the 1, and longest I don't have anything, so I'm starting with the 0. Okay, see this. Okay, starting from the 2, position of 2, it is 2, that is greater than 1, it means that is sorted, so we will increment the 2. It means this current will tell us like how many elements till now have the sorted in the longest sequence, and longest will tell us what is the longest sequence. Came up to 3. So 3 is present at 0, but its previous one, 2 is present at 2. So that is not greater than. It means we have breaked the longest sequence of 1, 2. Okay. So it means we will make the longest, compare this with the longest and current, that is 2. And we will again make this current to 1 to track further. Now we came up to 4. 4 is present at 3 and its previous index, that is 3. 3 is present at 0. So 3 is greater than 0. It means this is the longest sequence. We will increment our current 1 to 2. Now came up to 5. 5 is present at 4 and 4 is present at 3. It means 4 is greater than 3. It means their position is further. So we will increment our current. And finally we came about. So we will take the longest variable, that is the 3. And it means this longest sequence that we have find out, that is 3. And finally our answer will be n minus longest that we have find out. Length is of the array n is 5 and longest is we have find out 3, and that will result to 2. Okay. So hope you got this approach. Now the problem is how you will maintain this. Okay. So we simply need to maintain 1, 2, 3, 4, 5. These indexes, these are fixed because array is 1 to n. So we can use simple array. Okay. Array of size n plus 1. If we will use array of size n plus 1, we will have every variable, and we can iterate over a simple for loop to from 2 to n, and we will check like if that particular index for that particular element is present, is greater than or not. Okay. So hope you understood this problem. So let's see the code, how we will. So I've written the Java code. If you're comfortable with Java, you can refer this. So what I'm trying to here is like this is the array dot length just, and this is the position array that I've defined this data structure. Okay. So this is the position array. I'm initializing with n plus 1 because we have to store every element 1, 2, 3, 4, 5. Okay. And I'm doing the position of array of I is equals to I. What does mean by, like, let's see this one also. Consider I have this for this element, consider this is a position array. Okay. So 1, 2, this is 0, this is 1, this is 2, this is 3, and this is 4, this is 5 index. Okay, this is position array. How we will make this position array? So position of array of I, what I'm trying to say here, this is I. So array of I, it means I 0. So position of array of 0, basically that is 3. That is equals to I. So it means this is 0. Okay. You can see if I equal to 0, okay, array of I will be 3. Okay. And so it means position of array of I, that is position of 3 is equals to I, that is 0. Okay. So that I'm trying to say basically nothing, but you can use hash map or something also. We basically trying to store is what is the value stored with the whichever the index you can store in the hash map also, and you can quickly get it. The time complexity will be remain same, but I've used the array here, and like we can use the hash map also. Okay, because we just need to store the value comma with their indexes. Okay. Similarly for this I, okay, so what it will going to store position of array of 1, that is 1 with their index 1. So 1. Position of array of 2, that is 2 with the index 2. So it will 2. Position of this index, position of array of 3, that is 4 with an index 3, and position of array of 4, that is 5 with index 4. So if you will see, this will give the same like data structure. Okay. And from this, we will find out where it is going to be stored. And then now we will compare from here. If position of 2 is greater than 1, we will increment our current. If position of 3 is greater than position of 2, no, it is not greater than. So we will mark the current as 1, and we will take the longest, maximum longest we will track. Okay. Position of 4 is greater than position of 3. Yes, it is. So we will increment the current. Position of 5 is greater than position of 4. We will increment the current. And if we reach out, we will just compare the longest. We will take the longest one among the longest and current, and we will return it out. Okay. So that simple thing, like this is position of array of I equal to I. We can use map also as we have discussed. And I'm just initializing current one with n longest 0, and I'm 2 to n. I'm going, why I'm going 2 to n? Because I have every element from 1 to n. So I have to also check n element. Okay. And now I'm checking if position of I is greater than position of I minus 1, then I'm incrementing current. If it is not, then I'm checking the longest one, and I'm initializing current with 1. So for the next sequence to find out. And then I'm checking the longest one for the, like, consider in this example also. So we have the current is 3, and now till now longest is 2 because of the previous sequence. So to concluding the last sequence also, I'm doing this, and finally I'm returning the array dot length minus longest. To run this, it will, yes, we'll submit this problem. Okay. So hope you understood the problem. You have to make sure of these two approaches. First, you have try to dry run few examples. You will get it. And the most important part is you have to understood like how you came up to this approach. Now it's very easy to write the code for using array technique or the map technique. But the point is you have to come up to this approach to think like how we are going to store and what is the like n minus longest array sequence consecutive sequence that you have to find out. Okay. So hope you understood the problem. If you like and learn something new, please subscribe my channel. And I've also created a tree playlist. I will also test the link of the tree playlist. You can watch that. And thank you, everyone.